So we're going to be looking at 1.63. This one's right here. So 1.6, let's read the question first, figure out what we're looking for. Gold can be hammered into extremely thin sheets called gold leaf. An architect wants to cover a 100 feet by 82 feet with gold ceiling that is 5 millionths of an inch thick. So that's going to be important. The density of gold is 19.32 grams per cubic centimeter, and gold costs $1,654 per troy ounce. And then we have that unit of conversion. How much will it cost the architect to buy the necessary gold? Okay, so first let's look. We're going into dollars. That's what we're looking for. Into dollars. How much is the architect going to have to pay? So what we're starting with is a volume, which seems a little confusing. It looks like we're starting with an area, but we're not. So it's 100 feet by 82 feet by 5 millionths of an inch. So this is volume. It's going to be 100 feet by 82 feet by 5 millionths of an inch, which is 5 times 10 to the negative 6, because that's the millionths place. That's where the 5 is. Scientific notation makes it a little easier. So this is what we're going to be starting with, this volume. But if we're because we're given the density in centimeters cubed, we have to take it from this monstrosity here into centimeters cubed. So let's go. That's going to be our first step. Let's put this in the dimensional analysis. So we're going to have 100 feet by 82 feet, and then a different unit, 5 times 10 to the negative 6, inches. So this is going to be on our top line. And then let's start, we're trying to get into centimeters here, centimeters cubed. So let's start with this guy right here, inches, because it's going to be more straightforward. So we're going to bring inches to the bottom, 1 inch, and then centimeters, 2.54. Just want to make sure I didn't mix those up, centimeters. So now we've got inches into centimeters on this one, so we can cancel these out. But now we have to get feet into centimeters. So the next step is going to be getting the both of these feet into inches, because we can't go from feet exactly to centimeters without having being some crazy conversion thing. So let's go into inches. So since we have 2 here, we're going to have to square it. So we're going to do 12, let's do the bottom first. 1 feet is 12 inches. Okay, and so we're going to square this. And the reason we squared this one and not this conversion is because this was only 1 inch, while we're having 2 feet times each other. So foot times foot is a square. So we're going to have to square both of these. And then to get it into centimeters from inches, we're going to have to square it again. So let's do that. So this time in 1 inch, sorry, I got to think. Oh yeah, 2.54 centimeters. Okay, so now this is squared again because it's 2 sets. So now, if we're looking, let's go ahead and also cancel these out. So the feet cancel out with the feet like this. Let me just put my hand out of the way. I gotta remember I'm making a video. And so then the inches here also cancel out. So now we have centimeters squared times centimeters. So we got centimeters cubed. So this is good. Now we need to get it into the we're gonna have to get the volume out. So we have our density here on the computer. No, if you can show that here on the computer. So now we have centimeters cubed. It's pretty much handed to us our next step, 19.32 grams per centimeters cubed. So let's draw that. The paper's not long enough. I wish I could have done it on the whiteboard, but I don't own any dry erase markers because, like, why would I? I never use them. So that's besides the point. That's not chemistry. So let's go ahead and take it into grams per centimeters cubed. So now, since centimeters are on the top, imagine this is just going longer. Centimeters cubed is going to be on the bottom. So in 1 centimeter cubed, it's told us on the computer, on the homework, 19.32 grams. And this is density right here. This is the density of gold. So that's going to be our next conversion unit. So now we have the mass on top. So we can cancel out the centimeters. And because we have the mass, we can calculate it. We're also told that 1 troy ounce is equal to 31 and whatever grams. So we can put it in, see how many how many troy ounces we need, because we know how many grams we need now. This is what we would have figured out. So now we need to put it, so grams at the bottom. I'm really not that great at explaining this, I'm sorry. It's okay. I'm trying my best. I'm trying my best, man. Thank you. Thank you, Noah. Okay. So, Noah's my friend. He's filming. Thank you, Noah. Dang, this is a long video. Okay. Because I keep getting sidetracked. I tell you, this is the Gen Z in me. Maybe I need a Subway Surfers video, so I can do this problem. Okay, whatever. Okay. I'm sorry. I know you have better things to do. So 19.32 grams. We're gonna bring that we're gonna bring the grams to the bottom. So from the computer, we're given the conversion. So 31.10346768 grams. So now we're gonna mark out these grams. And let me also mark up this centimeters just because we got rid of those when we brought them to the bottom. So, and what are we bringing to the top? Troy ounces. Now we're getting closer. Yeah, we're getting, Noah's shaking his head. He's not in the chemistry class, but he knows, like, we're getting there. No, ignore that. 1 troy ounce. I didn't mean to do that. 1 troy ounce. Sorry, Noah's smiling behind the camera and he's distracting me. Okay, 1 troy ounce. So now we have the troy ounces. What else are we given on the computer? Let's take a look, Noah. Oh my goodness. If that isn't exactly the conversion that we're looking for, dollars in troy ounces. Yeah, thank you, Noah. Thank you. So now we're gonna bring troy ounces to the bottom. 1 troy ounce is $1,654. Mark those out. And this is exactly what we're looking for. Here at the top, we're going into dollars. This is perfect. So now, if you multiply everything across the top and then divide by the bottom, which is pretty easy because it's the only thing you divide by the bottom is the 31 point blah, blah, blah. We're given some long 99,399. So that's a big number. That's a lot of, that's your number. Okay. So significant figures. Okay, let's take a look. So I'm already seeing right here, this one right here, 5 times 10 to the negative 6. This is only one significant figure. This is 2. This is also 1 right here. 100 feet. This is 1 sig fig. This is 1 sig fig. So it can't get any less than 1. So we know that we have to round this to 1 significant figure. So that's going to be $100,000. And that's our answer because the zeros are to the right of the non-zero number and they don't have a decimal point. So it is not, those are not significant. So it's only 1 significant figure. Significant figures. Okay. So the significant figures in my life are my parents. But in chemistry, they're the numbers. Thank you for watching.